Okay, so we're looking at the 4.4 notes, and we're going to be discussing scatter plots and correlations. So a scatter plot is just a graph that shows the relationship between two different sets of data. So we graph the two data sets as ordered pairs, like points in a coordinate plane. And scatter plots might be able to show trends in the data just depending on what the data is. So, okay, over here on our graph, we see this scatter plot. So X is the number of grams of sugar that are in a smoothie, and Y is how many calories the smoothie has. So example A says, how many calories are in a smoothie that contains 56 grams of sugar? So 56 grams of sugar was X. So when X equals 56, they're basically saying Y is what? Because calories is Y. So if you go down here, 56 would be, if you look at the x-axis of the graph, here's 54 and here's 58. So 56 would be halfway between 54 and 58. So if you go up halfway, this point right here has an x value of 56. So then we want to know how many calories that smoothie has. So go over and look at the y value, and the y value is 270 calories. Okay, let's go ahead, and we're just working on reading a scatter plot. Let's try another. So this says, how many grams of sugar? So it's asking for sugar, so that means we don't know X, are in a smoothie that contains 320 calories. Well, remember, calories is Y. So we're going to go find a point that has a Y value of 320. So if you notice right here is 320. That's this point right here. So this point has a Y value of 320. So if we want to know how much sugar it has, we need to look at its X value. So go down here, and it has 70 grams of sugar. And then it asks us, it says, what tends to happen to the calories as the number of grams of sugar increases? Well, if you look at sugar, that's the x-axis. As the sugar increases, so as you go farther to the right, the points get higher. So that means the calories also increase. So as the sugar increases, the calories increase. So more sugar means, as a general rule, more calories. Okay, we're going to have you guys try a couple. So we're still going to be using this graph. So it wants to know how many calories are in the smoothie that contains 51 grams of sugar. All right, so we would go look, and we would say 51 grams of sugar is, if this is 50 and this is 54, then 51 would be right here. Halfway would be 52, so just a little below half would be 51. And that has a Y value of 260 calories. Okay, so now let's go ahead and let's look at the next question. So it's asking you, how many grams of sugar are in the smoothie that contains 250 calories? All right, so the answer would be 52 grams of sugar. So this point right here is at 250. So if we go down and look at the x-axis, it's halfway between 50 and 54. So that would be 52 grams of sugar. Okay, so here's some examples of correlation. Correlation means basically when it's saying the two sets of data share a relationship, or if they don't. So if it is a positive correlation, that is like this example. If you see the set of points, they are going up in a positive direction. If you drew a line through those, it would have a positive slope. So positive correlation means as the x-axis increases, or whatever the topic is on the x, the data on the y also increase. That's positive correlation. Okay, negative correlation is like this. If you notice, if you drew a line down the middle of those points, it would have a negative slope, so it's a negative correlation. And it means as the data on the x-axis increase, the y-axis decreases. And then no correlation is like this scatter plot where it doesn't show somewhat of a line going through it. So if the data make kind of a line, then there's some type of a correlation. The closer they are to the line, the stronger the correlation is. And we'll be learning about this more in depth. Okay, so look at example 2A. It's comparing a person's age compared to the number of vehicles that they own or that they have owned. And so this one, if you look at the points, they don't really make a very much of a line. Like you don't see the points lining up in some type of a linear fashion such as this. They're kind of all over the place. So this would be no correlation. All right, now look at part B. Temperature of like the outside and coat cells. So if you can see that these definitely are kind of trending in a line, and they're going down. If we drew a line down the middle, it'd be going in a negative slope. So there is a negative correlation. And what that means in this case is the temperature is the x-axis. So as the temperature goes up, as it gets warmer, coat cells go down because it's getting warmer and you don't need a coat. Okay, so today we're going to write lines of fit. It's not a line of best fit. That's something different we're going to learn in the next couple days. It's just a line of fit. So your steps are to first make a scatter plot of the data. Decide if it looks like it can be modeled by a line. Does it have a correlation or not, is what they're saying. You draw a line that appears to fit the data closely. So you want to have about the same number of points above the line as below the line. And then you write an equation using 2 points on the line. Now this is very important. The 2 points you use do not have to represent actual data pairs. They don't have to be part of your scatter plot points. They have to be points on the line of fit. And I'm going to show you what that means. Okay, so looking down here, we have the scatter plot already made for us. It definitely looks like a line could represent this. So the x-axis is the years from 1960 to 2010, and the y-axis is the age, the median ages of American women at their first marriage. And so we're going to draw a line that closely approximates the data. Now, we definitely don't want to freehand this. We absolutely want some type of a ruler or a straight edge to go through it. So I'm going to just go ahead and draw a line, and then I may have to adjust it using my mouse just because I want to make sure I get it in a good place. Okay, so this is not quite a good line because you want about the same number of data points above the line as are below the line. So let's kind of adjust it here. So if we do this, there are, let's see here, 1, 2, 3, 4, 5, 6 above, and 1, 2, 3, 4, 5 below-ish. I think that's actually a pretty good line. We might adjust it just a hair. I think that's about as good as it's going to get. Okay, so now you want to pick 2 points that the line goes through. It doesn't have to be actual data points from the scatter plot. Let me just see. All right, that looks like a little too low. I think I was better on my first one. I'm going to go ahead and undo that. Okay, so we need 2 points that the line goes through fairly well. So for example, we could have this point it clearly goes through, and that's 2010 and age 26. Now, we are going to actually write that point as, that's going to be 50, 26. And the reason for that is because it says, write an equation of the line. Let x represent the number of years since 1960. So 2010 is 50 years after 1960. That's why I did 50, 26, not 2010, 26. Okay, we need another point this is going through. So I'm going to go with kind of right here. This looks like something I could estimate. So the line, now I'm not worried about where that point, like the dot is. I'm worried about right on the line right here. So that's 1970. That's 10 years after 1960. And it looks to be halfway between 20 and 22. So we can call it 21. So now to write the equation of a line, we've been doing this for a while. So we can first find the slope. y2 minus y1 over x2 minus x1. Oh, sorry, I wrote that wrong. 50 minus 10, there we go. So I get 5 over 40, which is 1/8. So there's my slope. So now remember, you can use point slope form or y equals mx plus b. I'm going to go ahead and just choose to use point slope form. So y minus y1 equals the slope times x minus x1. And I opted to use this point, but either point would work. Okay, so now if I go ahead, 1/8 times x, 1/8 times -10, I'm just going to call it -10/8, and then we'll use the calculator and write it as a decimal in just a second. So let's add 21. All right, so I get y equals 1/8 x. Now we have -10/8 plus 21. So like I said, this would be a good time to just go ahead and to use your calculator. So if we have -10 divided by 8 plus 21, we end up with 19.75. Okay, and it says, what conclusions can you make from the equation you wrote? All right, well, your slope is 1/8. And remember I told you guys the top is y, and that's age, and the bottom is x, and that is number of years since 1960. So I could say that the average rate of change is the marriage age is going up or is increasing 1 year for every 8 years after 1960. So like every 8 years after 1960, the median age of marriage increases by 1. So like women are marrying 1 year older every 8 years. So use your equation to predict the median age of American women at their first marriage in the year 2020. Well, first of all, 2020 is 60 years after 1960. So x is 60. So we're going to then plug in 1/8 times 60 plus 19.75. All right, so we're going to do 1/8 times 60 plus 19.75, and I got 27.25. So that's going to be approximately just over 27 years old is the median age for women marrying if this pattern holds true in 2020. Okay, so I went ahead and graphed this table. So on the x-axis I have weeks. It goes 1 through 8. I'm going by ones. And on the y-axis I have sales in millions, and I'm going by twos to make sure it fits. And then I graphed the table as a scatter plot. Go ahead and pause your video and complete your graph now. Okay, so we graphed that. So now we're going to go ahead and figure out a line of fit. And remember, a line of fit is just our best approximation. We make the scatter plot, and then we are going to go ahead and decide if it is linear. It looks like it could definitely be a line. It has a negative correlation. Then we're going to draw in a line, and we're going to do our best to get approximately the same number of points above and below the line. So we're going to put a line in here. And so if we do this line, just kind of looking at where I've got here, and remember, we always use a ruler, we can't freehand this. So if we do this line, then we have 3 points above, 3 points below, and it's going through 2 of them. I think that looks like a good approximation. So now we pick 2 points on the line. So they can be actual points, like for example, this point right here is part of our table. That was the point 5, 10. So we can use points on the line that were part of the scatter plot, or we can just choose points that are just on the line. So for example, this point right here, this pink one, is not part of our scatter plot from our table, but it does show up on the line. That would be the point 3, 14. And so we can use 2 points on the line, but they don't have to be part of our actual data or the original scatter plot drawn. Okay, so now we're going to go ahead and we're going to use these points to write a line of fit. So what would the slope be using these 2 points? All right, so the slope would be 10 minus 14 is -4, and 5 minus 3 is 2, and -4 over 2 is -2. So the slope is -2, which makes sense because the line does have a negative slope. All right, so now we're going to go ahead and write our line of fit. So since previously I used point slope, I'm going to try this time with y equals mx plus b, slope intercept. I'm going to just go ahead and choose to go with this point 5, 10, but it doesn't actually matter which one. So 10 equals -2 times 5 plus b. Okay, so negative 2 times 5 is negative 10. And to get b by itself, we need to add 10. So that gives us 20 equals b. So our line of fit is negative 2x plus 20.